Lesson 18.3, Task 4. Solve real-world quadratic equations using the quadratic formula. Given a real-world situation that is modeled by a quadratic equation, you can determine the number of real solutions using the discriminant and then solve using the quadratic formula. In the metric system, the height h of t of a projectile is h of t equals, and here's the equation it gives, where h of t and h sub 0 are in meters, and v sub 0 is in meters per second, and t is in seconds. A volleyball player serves a ball overhead to start play. How long is the ball? At least 5 meters above the ground. Round to the nearest hundredth of a second. All right, so we want to know how long the ball is above 5 meters. All right, so the information that's given, the player serves a ball from an initial height of 2 meters and an initial vertical velocity of 9 meters per second. All right, so we're given this equation, h of t equals, and this is the equation they gave us above, and it says the projectile motion model. So the model just means the equation that we're going to use and substitute in the information that we are given. All right, so again, if you look up here above, it tells us that h of t and h sub 0 are in meters, v sub 0 is in meters per second, and t is in seconds. All right, so it says we want to find out how long the ball is at least 5 meters above the ground, and we're given that its initial starting position is 2 meters above the ground, and the initial vertical velocity is 9 meters per second. So if you substitute that in, h of t is what we want. We want to know how long it's 5 meters above the ground. Its velocity is going to be at 9 meters per second, and h of 0 is the initial height. So that is 2 meters above the ground. So we just fill in the information that we have, and then we can solve. So the first thing is we want to set this equation equal to 0. So they subtract 5 from both sides, and that's where the negative 3 comes from. Once it's in standard form, which means it's set equal to 0, we have the quadratic, the linear, and the constant term. That gives us our a, our b, and our c. So you can see they have identified a is negative 4.9, b is 9, and c is negative 3. Then they just plug it into the quadratic formula and simplify. So once we do that, they get all the way down to the last step, and then they simplify and they say t is approximately 0.438 and time is approximately 1.399. So if you think about it, you're going to have this volleyball is going to be a parabola, and it's an upside down parabola. We know it's upside down because the leading coefficient is negative, so it's upside down. So the part between the two times here will be above 5 meters, which is what we're looking for. And we know that because that's the number that we plugged in for the height. So that's what we solved for. All right, so the difference of those two numbers is going to be what we need. So 1.399 minus 0.438 gives us this amount, and this is in seconds because it's time in seconds, if you remember. All right, so it says complete the statement to explain how the equation was obtained. So the height in the question is 5 meters. That's what we wanted. And that's from the equation up here. That's what we wanted right here, 5 meters. And then it says the initial velocity and initial height. And that came from the image right here. Initial height is 2 meters and initial velocity 9. So the velocity was 9 and the initial height was 2 meters above the ground. All right, so what does the discriminant tell you about the solution? All right, so if I do the discriminant, remember that's b squared minus 4 times ac. That's the part underneath the radical, and that equals 22.2. So remember in the previous task, if the discriminant is positive or greater than 0, that means it has 2 real solutions. If that equals 0, it would be 1, and if it's negative, there would be no real solutions. So the fact that it's 22.2 tells us it has 2 real solutions. What do the 2 values of t that are the solutions to the equation represent? All right, so they give us 4 choices here. So the time when the velocity of the ball is 5 meters per second, the time when the ball is 5 meters above the ground and rising, okay, so that's true, and the time when the ball is 5 meters above the ground and falling. The height when the ball has been in the air for 5 seconds. Okay, so remember the 2 intercepts are the 2 endpoints, and everything in between those 2 points is where the ball is above 5 meters. All right, so it says complete the statements to explain why you subtract 2 values for t. So the graph of the function is a parabola. There is 1 point or 2 points on the curve where the function value, so there are 2 points where it's 5. The part of the curve in between those 2 points is the time period when the ball is at least 5 meters high. To find the length of the time period, you have to subtract the t values for the points. All right, so it says the ball is at least 5 meters above the ground for about 0.96 seconds. Why is only the final solution rounded to the nearest hundredth? All right, so you don't want to round each step. If you round in each step of the equation, then that means it's going to be a little bit further off each time you round. If you wait to the final step and you round, then it's going to be a little bit more accurate. So you never want to round, if possible, until the final step when solving an equation. All right, that's all for task 4. If you have any questions, let me know. Lesson 18.3, we're going to do another example just to make sure you've got good practice on using the quadratic formula. All right, so quadratic formula can be used when it's in the form ax squared plus bx plus c equals 0. So when it's in standard form, you can use the quadratic formula. All right, so we're going to first identify our a, b, and c. So a is 2, it's our quadratic term. B is 6, our linear term. And C is 2, our constant term. And if this is in standard form, it's always going to be A, B, C. But you do have to make sure you've got quadratic, then linear, then constant in that order. All right, then we're just going to plug in x equals, and you can go straight from the equation. So opposite of B, or negative B, negative 6 plus or minus the square root of B squared. B squared would be 6 squared minus 4 times A times C over 2 times A. All right, now we're just going to simplify first under the square root. Okay, so this is called our discriminant. So we're going to have 36. Negative 4 times 2 is negative 8. Negative 8 times 2 is negative 16. And remember, you do have to use order of operations always. So that's why we're simplifying underneath the radical first. So we're going to do 36 minus 16 is 20. And then 20 is not a perfect square, but I noticed that 20 has a number that goes into it that is a perfect square. So it's important to know what your perfect squares are, and it's important to know multiples of different numbers. So when we're dealing with square roots, we can rewrite 20 as 4 times 5. And 4 times 5 equals 20. I just rewrote it, and the reason I chose 4 times 5 and not 2 times 10 is because 4 is a perfect square. Okay, so when I have that, I know that I've got the square root of 4 times the square root of 5. We learned that in the previous lesson, that this is just multiplication. That's rewriting this using multiplication of radicals. So we're going to have negative 6 plus or minus. Now we know the square root of 4 is 2. Square root of 5 is not a perfect square, so we leave it there and have the 4. Now one thing I do want you to notice is that 6, 2, and 4, if all three of these have something in common, which means they can be reduced by a common term, then you do need to reduce those. So 6, 2, and 4 are all multiples of 2. So in order to get your best answer, or one that you would see on a test, you would have to reduce each one of these by 2. So just think about dividing each by 2 out, and you're reducing the whole term by the same amount. So negative 6 divided by 2 is negative 3, plus or minus. If I factor 2 out of 2, that just leaves 1. You can put a 1 there, but you don't have to have it. It's assumed to be a 1 when there's no number there. And 2 goes into 4 2 times. All right, so this does represent 2 answers, but most of the time when it still has a radical in the answer, we leave it as negative 3 plus or minus the square root of 5 over 2. Now it does represent x equals negative 3 plus the square root of 5 over 2, and x equals negative 3 minus the square root of 5 over 2. So in the other example from the task, when we had these were just numbers instead of square roots, they were whole numbers, then we could simplify further and just get x equals 2 or negative 3 or whatever. But in this case, because this is an irrational number, then we leave it like this. You may see it like this, but that's how you use the quadratic formula. And if you wanted to know what an approximate answer is, like if you were to graph this solution, you could also use your calculator to find an approximate solution. So to do that, you could type in negative 3. We do want to put parentheses to signify that this is on top, because again, order of operations matters. So negative 3 plus the square root of 5, and then that's in my numerator, and I want to divide that by 2. So if I want to know what the approximation and a decimal approximation of this number is, it would be this number here. And I could do the same thing on the other one, so I could do negative 3 minus square root of 5, close my parentheses, and divide that by 2, and that would give my other approximate answer. So this is the exact answer because it's not been rounded. This would be the approximate answer, but these two answers are equivalent to this. But this may be helpful if you're looking at a graph and you see the picture and you can see the x-intercepts cross between negative 2 and negative 3, then that would make sense. And this one would cross between 0 and negative 1. So that kind of gives you an idea of how to tell if you want to check these by graphing this equation. All right, that is all for the quadratic equation. If you have any questions, let me know.